Good morning, Kalai. Can we start
Good
our
morning.
discussion today?
Yeah, you can. Yeah, sure. I'm ready.
Before I go into the Krebs cycle, I will give you an introduction about the Krebs cycle. The Krebs cycle occurs in the mitochondrial matrix of eukaryotes or in the cytosol of prokaryotes. Do you know others name for Krebs cycle?
Wait, let me check.
Okay.
Is it citric acid cycle?
Yes, it's correct. It's called citric acid cycle. Without delay, I will start my explanation now. So the Krebs cycle starts with acetyl-CoA. The acetyl group of acetyl-CoA will combine with oxaloacetate to form citrate. Acetyl group is 2 carbon. Then the oxaloacetate is 4 carbon. So what do you think about the number of carbon in citrate?
Is it 6 carbons?
Yes, it's 6 carbon. Here you can see citrate got 6 carbon. Then this citrate is converted to its isomer, that is isocitrate, also 6 carbon. The next step, the isocitrate is oxidized and undergoes decarbonylation to become alpha-ketoglutarate. When the isocitrate is oxidized, this means that the NAD here, NAD plus here, is reduced to produce NADH. When the isocitrate undergoes decarbonylation, 1 carbon dioxide is produced because the term decarboxyl means that 1 carbon is lost to the formation of carbon dioxide. Here you can see the NAD plus is reduced to NADH and 1 carbon dioxide is formed. After that, the alpha-ketoglutarate undergoes once again the oxidative decarbonylation, which means that alpha-ketoglutarate is oxidized and undergoes decarbonylation and added with coenzymes A to become succinyl-CoA. So what do you think the product from this reaction? What is produced?
Is it ATP?
No. When undergoes oxidative decarbonylation, the same process as above.
CO2.
Yeah, CO2. Then what is reduced in this reaction?
NAD plus.
Yeah, reduced to what?
Reduced to NADH.
Yeah, correct. Then the coenzymes A of succinyl-CoA is replaced by the phosphate group. This phosphate group is then transferred to ADP diphosphate, only 2P, forming ATP triphosphate. So result in the formation of succinate, that is 4 carbon. In this process, ATP is produced by substrate level phosphorylation. You can see here the ATP ADP plus 1P and become ATP. That is mean adenosine triphosphate. Understand?
Yeah, sure, understand.
Yeah, okay, I will continue. The succinate, 4 carbon, is then oxidized to become fumarate, also 4 carbon. But when it is oxidized, something there can be reduced. So what is reduced here? FAD will become what?
FADH2.
Yeah, correct. In this process, FAD is reduced and FADH2 is produced. Moving on, the fumarate will produce malate with the addition of water. You can see the addition of water here. Lastly, the malate is oxidized to produce oxaloacetate. When it is oxidized, what is reduced?
NAD is reduced to NADH.
Yeah, correct.
Yes.
Easy, right? The Krebs cycle. Can you understand?
Yeah, I can understand.
Okay, let me ask you a question. Can you give me the product of the Krebs cycle?
Do you want me to state the number of molecules as well, or just the product?
Of course, I need the number of the product.
Okay, so let me guess. 3 molecules of NADH is produced.
Yeah, correct.
1 molecules of FADH2.
Yeah.
1 molecules of ATP and 2 molecules of CO2.
Yeah, correct. But it's only 1 chance of the Krebs cycle, which yields 2 carbon dioxide, 1 FADH2, 3 NADH, and 1 ATP. But each molecule of glucose will produce 2 chains of this Krebs cycle. So what do you think the new number of the products?
So since it undergoes twice, so the final product will be 6 molecules of NADH, 2 molecules of FADH2, 2 molecules of ATP, and 4 molecules of CO2.
Yeah, it's correct.
Yes.
So it's complete for the Krebs cycle. Do you have any doubt?
No, my doubt is all cleared by you. Thanks for the PAL organization for organizing this meeting to make me understand about the Krebs cycles.
Okay, thank you, Kalai. Later, I will share quizzes for you to have a better understand about your knowledge.
All right, sure. I will try to answer the quizzes.
Okay, thank you. you.
Thank you.